Welcome to another segment of device. In this segment, we are going to discuss Cmos, which is mostly used in every electronic appliances. Cmos is used in computer hard disk and in random access memory to store permanent and temporary information. Cmos or complementary MOSFET is an active device consists of one N-type MOSFET with source S, gate G, drain D and body B, terminal and other P-type MOSFET with the same four terminals. PMOS transistor. The P-channel MOSFET has a P-channel region between source and drain. The drain and source are heavily doped with P+ region and the body or substrate is N-type. The flow of current is positively charged holes. When we apply the negative gate voltage, the electrons present under the oxide layer are pushed downward into the substrate with a repulsive force. The depletion region populated by bound positive charges which are associated with the donor atoms. The negative gate voltage also attracts holes from P+ source and drain region into the channel region. NMOS transistor. The N-channel MOSFET has an N-channel region between source and drain. This type of MOSFET, the drain and source are heavily doped N+ region and the substrate or body is P-type. The current flows due to the negatively charged electrons. When we apply the positive gate voltage, the holes present under the oxide layer pushed downward into the substrate with a repulsive force. The depletion region is populated by the bound negative charges which are associated with the acceptor atoms. The electron channel is formed. The positive voltage also attracts electrons from the N+ source and drain regions into the channel. Now, if a voltage is applied between the drain and source, the current flows freely between the source and drain. Symbolic representation. The symbolic representation is as shown. It consists of one PMOS and another NMOS. Working principle. Both a P-type and N-type transistor have their gates connected to the same input. The P-type MOSFET will be on when the N-type MOSFET is off and vice versa. The networks are arranged such that one is on and the other is off. CMOS transfer characteristics. When the input voltage Vin is equal to VDD, we get a low output voltage which is mostly equal to 0 and vice versa. Since it inverts the logic level of input, this circuit is called an inverter. In today's lecture, we have learnt CMOS internal structure, symbolic representation of CMOS, transfer characteristics of CMOS. With that, we are at the end of this lecture. In the next lecture, we will discuss another topic. Thank you and goodbye.